Okay, we're going to draw these three angles. So I'm going to give myself a quadrant picture. Okay. So I'm going to start rotating in that direction, right? Spinning. Okay, this half circle would be a pi, and in my head, this is in my head, 3 pi over 3 is 1 pi, right?
Yep.
Okay, that's 1 pi, which is 3 over 3. What would the whole circle be? 6 pi over 3. So I keep going. And then I have to go more yet, because I have to get to 7. So one more third. And that's where I land.
So is just less than half.
Yeah.
And if it was
Like
half,
if you visualize cutting that into thirds.
right. Yeah. Okay.
Like, you know what I mean? Like a pie.
Yeah.
Okay, does that make sense? I'm using that in my head number all the time. 1 pi will be whatever fraction the same, right? Okay. Negative means that you have to start rotating downward. So a full pi would be a 3 over 3, and we don't go that much. So think about going two-thirds of the way.
Like that.
Okay?
You go fully around, and then since the leftover number 7, it's 1, and then just a little bit.
Okay, so another negative, so we're going to have to think about this rotation. Okay, we're going to be past a circle. I already can see that, right? Because a full circle would have the number 12 over 6. Okay, so here I go. I'm going to mark that on the side as a 6 over 6. Now I'm at 12. A full circle is 12 over 6. What's the next half circle number? If I went in 18.
Yeah, you're right.
Now I'm at 18, 6. And so I'm just going to go a little bit more. That kind of makes sense?
Hold up. Okay, Does that make sense?
Yep.
18, 6 times 8.
You go 3 semicircles.
Because all the way around is
2 pi. 1 pi is a semicircle, right? And you just said, isn't it 3? Well, yes, but it's 3 semicircles, not 3 full circles. Does that make sense? Which is what we did. We went a semicircle, a semicircle, semicircle.
And that's because the thing that we did yesterday with the dividing it by pi or whatever, and then it's 180 a rad or
Why don't we
something?
just convert it
Mhm.
to angles?
You could, yeah.
Oh, hack.
But
That wasn't fast.
thanks, Cohen. I'm now going to make you have no calculator on your test if that's what you want to do.
I'm going to figure out how to manually do it.
Okay. Same kind of idea here. We're going to do a formula called arc length.
Oh my gosh.
Okay, so arc length is, again, if I could put a string around the outside of a circle. That's what an arc is. Okay, you can't measure with a ruler. So like this is me saying like what is the arc length of, obviously a whole circle would be called the circumference, but now I can find partial amounts of the circle. Okay, so the formula is on a formula sheet. You would get provided for it on a test, on an exam. S says the arc length, don't ask me why they pick an S, equals the angle times the radius. we should, I'm going to write this at the top here. So arc length, whatever. Anybody want to guess why there's an S there for that? Maybe Latin? I don't know. The angle, but this is important. When you put the angle in, it has to be a radian angle. Don't put degrees in. And then this is the radius. Does everybody know what a radius? Does everybody know what a radius is? Like that, right?
Yeah.
What if I trick you and put a diameter in? Do you know what to do? Divided by 2. Because there's going to be some questions in your booklet that will have something about diameter. So make sure you remember diameter is twice as long. Okay, so a circle has a radius of 20 and a central angle of 60 degrees. So what's the arc length? So if you need a visual, like that's what I'm trying to figure out. What is the distance along that arc if I could measure it with a shoestring? Okay, so arc length equals the angle, which is 60 degrees, but I'm not allowed to use degrees. So I'm going to do this right in the formula. I'm going to keep that there. But how do I change that degrees to radians from yesterday?
Oh.
I'm going to give you multiple choice. Should I times it by 180 over pi or pi over 180? Those are your two options.
Divide. Yeah.
What was my little
180
trick?
over pi.
Yeah.
What was my trick?
Divide by what you want to get rid of.
Divide by what you want to get rid of. So I want to get rid of
3
degrees.
times pi. No, it's 50.
This chair's goated.
Okay. Now that angle is actually in radians.
There's
Times.
not the little button on your calculator.
It's not. No. It doesn't just do something for you. Okay.
What does that do?
I want you to practice typing this. This is all one big type. And on a test, on an exam, I deduct you points if you do not do it properly to 3 decimal places. And you would need units on this. Okay, so see what you can do.
Where's your calculator?
Let me practice it.
Practice the typing, see how it turns out.
Reese, you also need a calculator.
20.94. I just looked
Oh, sorry. I thought I gave you one, and then did I take it back?
Yeah. 20.94. Here, you try.
Do you just need a second calculator over there?
Sure, yes, please.
Whoa, sorry.
Oh, it's a good one. Get right. Oh, you're just the same.
Mine's number 1.
Anybody
Oh.
have a match to that? Accurately to those
Oh, wait, no,
3
60 times pi.
decimal
So
places?
0 doesn't count as a decimal point then?
What? Where am I looking at the 0 on that one?
No, I mean on
Never mind, yeah.
like turning the degrees into radians.
This symbol,
Yeah, because I got 1 point.
like this is just a symbol. It's not a number. Is that what you were doing? You thought it was like 600? Or would?
I mean,
Not even number.
when I got my radian,
Yeah.
it was 1.047.
Oh, I don't know. I didn't even do it. I just typed this all in one step.
Really?
Yeah. Because you shouldn't get your radian number and round it and then try to times it. There's never any rounding until your end. So you're thinking you did this. So this is what you did in radians, which is fine, but you can't stop and round that. You would just have to say that radian times 20. You know what I mean? You don't stop your number, just keep going with the number that you have on your calculator. Did you stop and write down that 1.0 whatever number?
Press the bracket button.
Yep.
Nice.
Just keep it on your calculator.
But I just figured it out.
And then continue your timesing by 20 after, but you have it still on your calculator, not
I
rounded.
feel
Is
that.
that what you're not supposed
You know what I
to do?
mean?
You
It's
can.
on your calculator, so keep it there. Don't erase it.
'Cause then you can look like a genius, don't I?
You just spend so much time.
Okay.
With your brackets.
A clock has a minute hand with a length of 4 inches.
Also big.
So that's my radius, right?
Convert to centimeters.
Right now it's 3:15. What time will the minute hand be if it travels an arc of this?
Yep.
Okay.
9 o'clock.
So I told you that the radius was 4, so you can put that in for the r.
Yep.
And I told you that the whole arc, the outside of the circle, was 18.85. Now I'm going to figure out the angle. So I'm going to divide by 4.
Just data. This is basic chemistry. 18.85. Oh, shoot.
4.713.
Okay?
Degrees?
Now
Radians.
that is a radian
Oh,
angle, right?
right,
Because
right.
that formula works with radians. Your brain doesn't function with radians, does it? You're like, you see that and you're like, I don't even really know what that looks like. So let's convert it to degrees. So I'm going to take that number, and guess what? That number has not left my calculator. I do not round that number. It does not move from my calculator. It's in radians. Multiple choice. Should I times it by pi over 180 or 180 over pi? 180 over pi. And then I'm in degrees. And I have not rounded anything
270.006.
until now. That's the first time I round anything, is when I'm done. Okay.
Oh, it's kind of triggering that you can't just say
Now, I gave you a little bit of a word problem just to make you think. We're talking about the minute hand. Where is a minute hand if the time is 3:15 in the afternoon? Where would you put the minute hand?
At 0. It's like 360.
What?
Look at the clock. If it was 3:15, where would the minute hand be pointed to?
At the 3.
At the 3.
The 0360 line.
Okay,
But it points all the way to the end.
that's where a minute hand would be, right? Are we in agreement?
Yes, yes, yes.
3:15. That's where I'm going to look to find the minute hand. If that minute hand travels for 270 degrees, where would it land?
270.
If it traveled
No.
as a clock, this is now as a clock.
It would be
Like 7 o'clock.
It would be 4 o'clock.
This,
Yeah, it would be.
this.
Look it would be 4 o'clock.
But it'd be on the opposite direction. We look at a clock differently.
At 12 o'clock?
If it went 180,
It'd be 4. Look it.
If it went 160. Oh, that's the hour hand.
What time would it be?
No, it would move 45 minutes.
oh,
I'm with
you're
you right
saying
now.